What is going on YouTube? You are watching JayzTwoCents, and if you can't tell by the title of this video, this is way overdue, but I wanted to make sure I brought it to you right. And this is going to be my Intel overclocking guide, and this is a live commentary, so you may hear some dogs barking, you may hear some helicopters flying, you might hear some fans going. It's really hot where I live. In fact, today it was over 108 degrees, and it's not even July yet, but whatever, I digress. This, what you're looking at right here, this is my desktop, and this awesome right here, this isn't for me, this is for you guys because of all of the support that you've given me through this entire YouTube venture. I just wanted to go ahead and let you guys know that you are awesome, and for that very reason is why I'm doing the giveaway in my previous video, the infomercial I did for Tilt. I'm linking it right here, shameless plug, go and check it out, enter to win one of those amazing power plant battery packs for your mobile device. You know you want to win it, so go check it out right now. Pause the video, go over there, watch it. It's only 2 minutes long, and you could be winning yourself a $90 battery pack to keep all of your mobile devices charged. So with that out of the way, first of all, this is do it at your own risk. There are no guarantees when it comes to overclocking. There is no guarantees you won't fry it. There's no guarantees that your chip will even overclock. Overclocking is 100% luck of the draw. You may get a good chip, you may get a bad chip, you may get a mediocre chip, but whatever, you can just keep your fingers crossed and hope that you get at least a few hundred extra megahertz, and if you're lucky with AMD, or excuse me, with Intel, you may get a gigahertz or more. So keep your fingers crossed. And let's go ahead and talk about some programs that you're going to need when it comes to stability testing, because simply getting your computer to boot with your overclock is not good enough. You have to make sure it's stable, especially for the different tasks that you perform. So starting from these programs right here in this square. Oh, and by the way, when it comes to recording my desktop, because I know you guys are going to be asking, I am using the Elgato Game Capture HD. It is a HDMI capture device. I just have it capturing my monitor, and we're recording it on the laptop, including my microphone, my Blue Yeti. Here we go, starting left to right. You've got OCCT. This is a stability program. As you can see right here, it's loading. You got a bunch of guys hammering on their computers because I guess metaphorically, that's kind of what you're doing when you overclock. So it's got some warnings here. It's telling you it's not for commercial use, blah, blah, blah. A lot of information about your system is displayed right here. You've got a moving graph here when it comes to your core temperatures, voltages, frequencies, usage. You have all the setup right here when it comes to your stability testing. We're not going to go into depth on how to use these programs. I'm just showing you the programs that I use when it comes to my stability testing. Next on the list here, we have IntelBurn Test. This is Burn Test right here. It's just a little bitty program, and it's got this little flame right here, which initially when I first saw this, it was kind of scary. I'm like, wait a minute, it says freeze test, and it's a flame. It's fire. That's scary. But what it is when you hit start here and it starts running its algorithm and testing your CPU, it's got this little moving image so that you can tell if you have a system lockup. So, I don't know, it's freeze test, but it's fire. It's almost kind of like an oxymoron, almost like a little joke. But anyway, we'll go ahead and stop that right now because we're not going to do stability testing. We've got Cinebench is what we use here for benchmarking. Once you have a stable overclock and you want to benchmark it to compare between your other overclocks, you can download Cinebench. It is free, and you have a 32-bit and a 64-bit version. This is what it looks like. Disclaimer, of course, and it basically just when you turn on the CPU for a rendering test, it just renders out this image with however many cores that you have, and we're not going to let that run because that's not what we're doing right now. When it comes to hardware monitoring, I've got two programs, Hardware Monitor and CPUID. Hardware Monitor shows you everything going on with your system. I've showed you this program in the AMD video. If you expand this here, it shows you a lot. Shows you what motherboard you're using right here. It shows you the voltages. Now you're going to want to kind of ignore these voltages for the most part. I mean, their software monitoring of voltages is, I mean, it's mediocre at best. It's usually very off from where the voltage meter shows. So ignore the voltages here. You've got some of your different temperatures here. You've got fan speeds. Mine tends to freak out. As you can see, it thinks that my fans are running like, you know, jet turbine speeds at 65,000 RPMs. It's because I have some fans jumpered together and weird things like that happen. So just kind of ignore that. But you got your core temperatures here, including your package temperature. So if you want to understand, for instance, my 3770K has 4 cores 0 through 3, and right now they are currently running in the 30s, and you've got here your value, which is current, your minimum recorded, and your maximum recorded. And then package is the entire socket, what all of those cores, including the socket, make up when it comes to the die. We've got your powers here, which is right now it's showing that I'm using about 23 watts at idle. This number does jump around. Again, when it comes to your power consumption, it's software monitoring, it's mediocre at best. And then it's going to show you, all the other temperatures for hard drives, graphics cards, and whatnot. And look, my graphics card's running at 29 degrees. That's nice. My phone just fell over. Fail. All right, so there you go. This is what I use when it comes to monitoring. And last but not least, to verify your overclock, you use CPUID. This brings up here just a little bit of information. As you can currently see, I am running a 3770K, 1.265 volts, and I am running at 4.7 gigahertz right now through a multiplier overclock. And then you can click memory here to see what's happening with the memory. You can see I am using DDR, which is double density RAM, at 1000 megahertz times 2, because it's double density, running at 2000 megahertz on the RAM right now at 1011, 1030 clocks. So there you have it, guys. So what you're gonna go ahead and do right now is we're gonna go ahead and we're gonna reboot my machine. Okay, so now we're back in BIOS, and as you can see here, everything is in default. We're gonna ignore this Nick Sis overclock profile, because he does have profiles that he's added onto here. But what we're gonna go ahead and do right now is we're gonna turn on OC tweaking. You may or may not need to turn that on your board. Most boards, especially the ROG boards and other ASUS boards, they have a manual overclocking. You have to turn that on or on. So you're gonna have to consult the manual for your motherboard. But when it comes to overclocking the CPU, there's a couple of things that you're going to have to disable right off the bat. So for Intel, you're going to disable the spread spectrum, which it says right there in the right, in this area right here. It is suggested to disable when you're overclocking. So we'll go ahead and do that. Disable it. Multi-core acceleration, you want to keep that on, obviously. Intel Speed Step technology, you're going to leave that on. And the Intel Turbo Boost technology, you can go ahead and leave that on. Additional turbo voltage, what that means is when you're overclocking and the turbo mode engages, where the multiplier changes, it'll add more voltage. We're going to leave that as it is. And internal PLL overvoltage, that is going to be enabled. That you're going to enable that if you're starting to push about 4.6 or higher. So unless you're going 4.6 or higher, just basically leave that where it is. All this other stuff when it comes to short duration, power limit, power primary plane, and all that stuff, leave that on auto. That's very advanced stuff. And most importantly too, when it comes to your RAM, I do have 1866 RAM in here, but we are going to leave this, we're going to set this static. What I mean by static is we're telling it what to put in there, not letting it use an auto feature at 1333, because you want to make sure that when you're checking for overclock stability that you're leaving the RAM out of the equation, because the last thing you want to do is be messing around with your CPU settings for days, or in my case with the AMD, as you guys may have known, months trying to find a stable overclock when it turns out all along it was just your RAM that was overclocked too far. So we're going to go ahead and leave that at 1333, which is just the default memory controller inside the chip, so we'll leave it there. It's a nice safe setting. We're going to go ahead and power saving mode disabled. That's good. Extreme voltage, we'll go ahead and enable that, and we're going to go down here to line load calibration. I leave mine at 1. That way it doesn't really reduce the voltage at all during load, because I have a really adequate PSU, or power supply unit. Very, very good one. It's a gold rated. It's a Corsair AX750. But of course, you need to make sure that you have the hardware to support your overclock. So you need to have a nice, powerful, efficient, and very stable power supply unit. Don't just go by the watts rating. There's a lot more to power supplies than just the watts rating. It's also the efficiency, the efficiency of the rail, whether or not it's a single rail, dual rail, quad rail, 12 volt. All that stuff matters, because if you have dirty energy getting into your CPU where the frequency and the power coming in is fluctuating all over the place, you can accidentally damage something. So anyway, internal GPU load line calibration, we don't use internal GPU, we'll leave that off. And when it comes to the voltage here, I like to use a fixed mode, and I like to start out at right about 1.2 volts. There we go. So that's where we're going to start it. We're going to leave things right here at the default 35 multiplier. Where did we go down here? How embarrassing. I have lost my old multiplier. Okay, there we go. Host, CPU ratio, all cores, and then stock is 35. Because the way this works with Intel is the base clock is at 100 times whatever the multiplier is, gets you your frequency. So base clock's 100, set that, all core to 35. So we're basically static here. We've told the computer, use these settings and ignore auto. So we're gonna go ahead and reboot that into Windows. We are going to perform our first stability test with IntelBurn Test. And I will show you guys that as we're going to go ahead and kind of chat here for a second as the Windows boots up. It should only take about 10 or 12 seconds or so. And I like to use IntelBurn Test when it comes to the initial testing of the overclock, and then or even just the base clock. And what I like to do with that is just leave it on standard because it only takes about 10 minutes to do its test. Open it up and then hit start. Let that go. It'll have, it'll run the test 10 times, as you can see right here. And then once you know you're stable, or it completes the test, stop, reboot into BIOS, and we're just going to pretend we finished that test because we know it's going to work at the base clock. Go back into BIOS, and then we are going to bump up that multiplier just a little bit. Okay, so here we are. We are back in the BIOS now. We are going to go ahead and immediately, let's just go ahead and jump right up to... let's go multiplier of 42. And the reason why I say multiplier of 42 is because it's most 3770 and 3570Ks, even your 2500s and your 2600Ks are more than capable of running a 42 multiplier without very much tweaking needed whatsoever. So once you do that, you can just F10 save and then reboot into Windows. Now it's really important. I can't stress this enough. You have to have adequate cooling. You can't just plop on the stock cooler and expect to get massive overclocks. You can only get it with the stock cooler. I wouldn't recommend you try an overclock at all. And even with a decent air cooler like a Hyper 212 or even a V6 or a V8 or even one of the Noctua coolers, I don't recommend that you push your overclock too far because air cooling is entirely dependent on the ambient temperature. And that's why I water cool, because I like to overclock as far as I possibly can. So now that we've rebooted with our new multiplier, you come to CPUID, and there it is right there, 4200 megahertz. So you can go ahead and run your Cinebench if you want to go ahead and test that and see how it does. And just for the heck of it, we'll go ahead and run Cinebench right now. This is assuming that you've gone ahead and done your stability test. For the sake of the video, we're not going to do a stability test every single time. We're just going to kind of assume that you guys have done it. Make sure every time you change a setting, you go back and you do your stability test. And once you get to an overclock that you feel is your maximum stable overclock, you then can run OCCT or even Prime 95. That's another program that I use for Intel, at least. I said I don't like it for AMD, but for Intel, it's perfectly fine. Run your Prime 95 for at least a few hours. A lot of people recommend 24 hours. I find that to be extreme overkill. Usually on Prime 95, if you're going to run into any problems, it'll happen in the first hour or two. So I ran mine the other day for 4 hours just for good measure, perfectly stable, and as you guys saw with my live stream the other day, absolutely no problems whatsoever. But this lighter color orange right here, this is the test we just performed, and you can actually see that compared to my 4.7 test right here, 9.56 versus an 8.54. It's a whole point difference just with a few hundred megahertz. So yeah, let's go ahead and save that score. Sure, why not? So let's go ahead and restart into BIOS, and let's go ahead and talk a little bit about voltages and RAM, and then that's pretty much it, guys. Intel has really made overclocking extremely easy. It is literally nothing more than making sure you have adequate cooling, good RAM, a good power supply unit, and changing a multiplier. Even if you change the base clock to 101, at least with my chip, if I change this base clock to 101, 1 megahertz faster, my computer won't boot. So, it is what it is. And my overclock that I use My 24/7 stable overclock is this 4.7 right here. I do have a 4.8 stable. It's just a little bit hotter than I'd like, because what you're going to notice as you start to bump up the overclock, and go ahead and ignore these other, these other numbers you see right here. This is advanced stuff here when it comes to the delivery of the power. But at 2000 megahertz on my RAM and a 47 multiplier right here, as you can see right there, 47 multiplier, I am running at 1.26, where'd you go? 1.27 volts. So as you can see, I didn't need much more voltage at all to get up to 4.7. But now let's take a look at the overclock that I needed for 4.8. So check this out. I just loaded my 4.8 profile. And if you look at the voltage, look at that, 1.29. And we're talking 100 megahertz. And I had to add a whole 0.02 volts. Now, you gotta understand, with the way it works with Intel, the voltages, once you get to about 1.26, 1.27 and up, start to get much, much hotter exponentially. I mean, if I was to take this right now, and I was to demonstrate, even with my water cooling, at 1.29, I'm going to reach about 74 to 73 degrees Celsius on the cores. But at 1.3, it starts to bump up into the high 70s. And at 1.31, I start to see low 80s. At 1.35 and up, I start to see 90s. And at 1.4, which is what it took for me to get 5 gigahertz on this chip, I started to see 100 degrees Celsius on the core. So I immediately stopped it when I saw those temps. But what does that tell me? It doesn't tell me that my cooling system is inadequate, because the heat coming out of my radiators was not even warm, whereas my AMD used to just feel like a furnace. It tells me that my chip suffers from the bad thermal paste that was used on Ivy Bridge, and unfortunately is plaguing a lot of Haswell chips as well. So guys, that is really it. Once you get onto a ratio that your CPU likes at a voltage that is nice and comfortable, and you get it stable, then what you do is you leave your CPU multiplier where it's at, and then you take your voltages here and you run your stability test, and you go, okay, I'm stable. So then you load back into BIOS, you reduce the voltage one notch, and you just keep performing that test, reducing voltage every single time you run that IntelBurn test. Once your IntelBurn test fails, bump it back up a notch, and then you run your test again. If it's stable, run it again. If it doesn't crash for a second time, then you run your Prime 95 or your OCCT for at least a couple of hours. If it fails, then you got to bump the voltage up another notch and repeat your long test. That's really all it comes down to when it comes to Intel. There is one other setting that you can try here for stability. It's the CPU PLL voltage. As you can see, the voltage showing here on the left, this is current. It's not going to match what's on the right because I loaded a profile but I haven't rebooted yet. You can bump this up to 1.815. It's actually 1.813, I guess. You can bump it up to that voltage for a little bit of added stability. That's where I've found that I've got the max stability right now, is at that particular voltage. Once your CPU is nice and stable, then you start bumping up your RAM frequency one notch at a time. And right now I found that 2000 is perfect. At 2133, my CPU fails to boot. But as you bump up your RAM voltage, or excuse me, your RAM frequency, you're also going to have to come to your DRAM voltage and bump that up as well. So as you can see, stock voltage for my RAM is 1.5 volts, and the value that I run it at for my overclock is 1.55. I'm pretty lucky that it didn't need a whole 0.1 volt to overclock. Sometimes the RAM, you have to bump up a decent amount as well to get an overclock. Fortunately, I don't have to do that, so we're good. I am going to reboot with these settings here. And we're going to go ahead and run Cinebench. And I'm going to show you one other neat utility that you can use when it comes to overclocking your RAM and checking for RAM speed increase and how well overall your RAM is performing. So anyway, if you're wondering why my Windows boots so fast, it is because I'm on a solid state drive, obviously. This is it right here, MaxMem. So we'll go ahead and move MaxMem over to here. We'll go ahead and start Cinebench. All right, so let's go ahead and load Cinebench 64-bit. Let's go ahead and run this in real time See, that's the cool thing about using a capture card like this, is I can actually run these benchmarks in real time for you guys, and you guys can see them. You can also see when I'm doing this video and what time it is. Look, it's 10 o'clock at night. The family's in bed, and we have to be quiet. I don't want to wake up my 4-year-old, because if I do, oh my God. If, the nickname for my daughter for a while there was Megatron. We used to call her Megatron because she was just, Anyway, this test is running nice and fast. 8 threads running here, 4 cores, 8 threads. Gotta love the hyper threading. And it's just about done. Yep, this is a benchmark of my 4.7 overclock. And look at that in the bright orange, 9.79. That other test that you saw where it was a 9.56, it didn't save it. That's weird. I got this boost because that 9.56 was that 1866 RAM. That was with my old RAM, my Patriot RAM. That would not overclock beyond the XMP profile of 1866 no matter what I did. However, I am running Corsair Vengeance in here now, and this is the first time I ran this test with my overclock at 9.79 at 2000 megahertz on the RAM. So as you can see, RAM plays a big part in the overclock as well. So there you have it. This was the first overclock we did together, and here we are right now after the fine-tuning and playing around with it. And as I promised, here we'll go ahead and take a look at MaxMem, and what that does is it just takes your memory, and once it's fully loaded up, you click Start Benchmark, and what it's doing now is it's testing all of the latency. It's sending information to your RAM and having it processed, and then it will benchmark the transfer speed of your RAM. And this Vengeance RAM, if you follow me on Twitter, I talked about, I will always use this stuff. Look at this. Memory copy, 27,008 megabytes per second. Memory read, 24,807 megabytes per second. Memory write, 23,080 megabytes per second at a 48.5 nanosecond latency. That is fast, people. That is extremely fast. My Patriot RAM was only at 19,000. There you have it, guys. Overclocking the Intel 3770k, the same process applies to 2500k, and Sandy Bridge and up. Sandy Bridge, Ivy Bridge, Haswell, because of the fact that they all use the same type of overclocking and multiplier, because you're not having to deal with a north bridge or a north side bus. There we are, 4.8. I loaded the 4.8 profile, and we are stable. So I'll probably bump it back down to the 4.7. Real quick, before I hop off here, why don't we go ahead and just run so you guys can see in real time what the temperatures look like and why it is so important to have proper cooling for your overclock. I cannot stress this enough. So on the left right here, we have got and we're going to just reduce this so you can see the core temps only. How's that? All right. Here is core temperatures with a package. Okay, as you can see right now, we're sitting in the 30s. Minimum was low 30s with a high of 39 over there, and then in the 40s and 47 max so far. But watch when I turn this to, let's say, maximum or maximum stress. It's going to use all the RAM available to it, and once I hit start on this, look what happens to these temperatures. Keep an eye on this. Boom! It's going to start to climb and climb, and I mean, I've got pretty good cooling on here. As you can see, we're just sitting at about 60, but the longer you let this go, especially with water cooling, the water temperature starts to warm up, and it's going to start to rise, and over time I'll probably see this 4.8 overclock sit somewhere in the 80 degrees range. So there you have it, guys. I know this was a long video. I know it's probably really boring, and I know it's long overdue. Just put down in the comments if you're having some trouble with your overclocks. Put it down in your comments what your settings are and what problems you're getting. You're going to get when you're testing this stuff, you're going to get lockups, you're going to get blue screens, you're going to get all sorts of stuff that's going to freak you out. And you're also going to notice that when you start to bump up your voltage and you hit that save and exit button from your BIOS, sometimes your computer's going to shut off. And I know when I first started overclocking, that really freaked me out. And real quick, as you can see the temperatures, look how high they're jumping up now. See this? So cooling, very important, people. So your computer may shut off on you. That's just the voltage regulators resetting, because they can only adjust so much with the current being sent to them. So they'll shut off, readjust to whatever voltages are you set, and then the computer will reboot. So it's very hard to actually break something with your CPU when it comes to overclock. If it's too much, it just simply won't boot most of the time. But there you go, guys. JayzTwoCents. Make sure you're subscribed, following for all these geeky type of videos. Put your settings down in the comments if you have any questions about your overclock, and if you're having some failure, do the best I can to help you out. More importantly, there's enough geeks following this channel now that there's other people that are going to be willing to help you out, because I can't possibly answer all of these comments. I do appreciate you guys watching and liking my videos. The support is amazing. And like I said at the start of this video, this awesome banner right here, this is for you guys, because you guys have earned it. It's JayzTwoCents. I'm out of here. Now go and overclock the crap out of your stuff.